Today I am teaching you the strength of material or mechanics of material. In that one, Sfd Bmd, particularly cantilever beam. A cantilever beam having a point load and a UDL, complete UDL. Now for shear force I am considering downward as a positive and upward as a negative. For bending, sagging as a positive and hogging as a negative. That means smiling face is positive, sad face I am considering as a negative here. Now first I will go for converting into point load. First I will convert into point load here. I will convert this into point load. Now here this is A 1.5 exactly at the centroid, because it is a UDL. Centroid is nothing but 1.5 into 1.5. If you calculate, the answer will be 2.25 kilonewton, because meter get cancelled. In UDL, this load into this distance you have to multiply. You will get 2.25 kilonewton, and the arrow has to be done exactly at the center. That is half. 0.75 from this side, 0.75 from this side. Similarly, there is a point load acting here at C. At C there is a point load 3 kilonewton. Similarly, there is a UDL here exactly at the center. The value is 1.5 into 0.5. The answer for this one is 0.75 kilonewton, and half of length, that is 0.25. Either side you will get 0.25. This is the C and this is B. Now C and B. Now SF. Now I am drawing the shear force diagram here. Shear force. Now SF at B. SF at B, there is no load. Therefore you have to take single letter. That is 0. There is no load here. Next at SF at C. SF at C there is a load. Therefore you have to consider left and right. SF at C. First I will consider right side. Right side there is only one load, that is 0.75 kilonewton. SF at left side is nothing but 0.75 plus 3, because downward arrow I have considered as a positive. If you add it, the value will be 3.75 kilonewton. Next at A. At A it is a fixed end, but there is no load acting. Therefore SF at A will be same value, 3.75 kilonewton. Now draw shear force diagram here. This is SFD diagram. The first value for A is 3.75 kilonewton. Next at C there are two values. First is 3.75. Oh sorry, I made a mistake here. SF at A, the previous value is 3.75 plus this value plus 2.25. If you add it, the answer will be 6 kilonewton. The first value is 6 kilonewton. SFC is 3.75. At the C one more value is there, 0.75. At B it is 0. Therefore it is an inclined line here. It is an inclined line. Why it is inclined line? Because it is a UDL. It is a UDL. Therefore the inclined line will be appears. Draw a line here. Again there is an inclined line. In this way you have to solve the problem of SFD. Now I am going to BMD. Now I will go from the left to right. First I will consider the BM at A. I will refer this diagram here. The first load is here, minus 0.75. Why it is minus? It is sad phase. It is bending in this way. It is bending in this way. Therefore it is sad. Therefore I have considered negative. 0.75 into distance into 0.25 plus 0.75 plus 0.75. Next, this load minus 3 into 0.75 plus 0.75 into this load minus 2.25 into 0.75. If you calculate, the answer for this one is minus 7.5 kilonewton meter. Kilonewton meter. Next is I will go for C. BM at C. This load, that is this part, minus 0.75 into 0.25. Answer is minus 0.1875 kilonewton meter. Bending moment at B will be 0. Draw the diagram. This is positive side, this is negative side. First value is A is minus 7.5 kilonewton meter. C will be minus 0.1875 kilonewton meter. It will be 0. Here, because of UDL, you have to draw parabola in this way. Because of UDL. If it is a point load, you have to draw a line. Because of UDL, you have to draw a parabola. Negative, negative. In this way, you have to solve the problem when the cantilever is subjected to completely UDL with a point load.